In this video, we're going to apply quadratic functions to solve real life situations. And the first example I have that we're going to take a look at is kind of modeling the path of a ball after you kicked it, and it gives you this equation that models that path, and that looks like it's written in standard form. It's not factored or written in that intercept form where it says x is the horizontal distance in feet and y is the height in feet. It says what is the height of the ball at its highest point and how many feet had the ball traveled horizontally at this height. So sometimes it does help to draw a picture. So if you imagine the ball is being kicked and it does something like that, and clearly it reaches some maximum height, and that occurs at, of course, the vertex, right? And basically what it's asking for is the height of the ball at that highest point. That height corresponds to whatever that y value of the vertex is. And then it is also asking for how many feet had the ball traveled horizontally at that point. That's the x value of the vertex. So essentially this is like a fancy way of asking for what is the vertex of that function. Now if you remember, if the function is written in standard form, the x coordinate of the vertex is going to be negative b over twice a, or the opposite of b over twice a. So in this case, the b value is 4, so it's going to be negative 4 over twice the a value, negative 0.1. So if we do that calculation, that's negative 4 over negative 0.2. And if you put that into your calculator and divide 4 by negative 0.2, I think you're going to get positive 20. So that's our x value. I can actually answer the second part of this question right now. How many feet had the ball traveled horizontally? That is 20 feet. That's the x value. So that is 20 feet. Now, what's the height? That has to correspond with that y value, remember? So we have to plug that into our equation. That's going to be y is negative 0.1. Then we have to do 20 squared, and I think I'm running out of room, unfortunately, plus 4. That's a terrible 4. Let me erase that. So it's going to be plus 4 times 20. So if we simplify that, 20 squared is 400. So I have negative 0.1 times 400. And then 4 times 20 is plus 80, right? So negative 0.1 times 400 is essentially like doing negative 1/10 of 400 or dividing 400 by 10. So that's going to be 40, but because it's negative, it's going to be negative 40. So essentially I have negative 40 plus 80, and that is 40. So the height of the ball is 40 feet. That is that maximum height. And let's maybe write that. It is not easy to write with this thing. I got to get a new stylus. So that is the height of the ball. Moving on to another example. It's a very similar example. You have the path of a place-kicked football, and it's modeled by another quadratic function where x is the horizontal distance, just like it was above, but now it's in yards. We want to pay attention to units, and y is the corresponding height in yards as well. How far is the football kicked? Now, that's not asking for what's that halfway point, or what's the horizontal distance at the maximum height. It wants to know this whole distance, okay? And then it also wants to know what is the maximum height here for that football. Now, because it's written in intercept form, we have this negative 0.026x times x minus 46. The way we go about finding the vertex is a little bit different. If you remember, the vertex is somewhere on the axis of symmetry, which we use that formula p plus q over 2, or the two intercepts over 2. Now, because this is x, the first intercept I'm going to use for p is 0, and since this is x minus 46, the opposite of negative 46 is positive 46. That's my q value, is 46. Now actually, if you think about it, we can answer the first question This intercept here is at 0. This intercept here, where the ball lands on the ground again, is at 46. So the overall distance from where it's kicked to here, that's 46 yards. So I can write 46 yards. That actually wasn't that bad. Now the maximum height occurs right in between 0 and 46. So the halfway point between 0 and 46 is just, what, 23? So I know the x-coordinate of the vertex is 23. Now that's not the height, right? That's just where the x value is. So to find the y value that corresponds with 23 yards for x, I have to plug it in. So I have to find what is y equal to when I do negative 0.026, and then do 23 here, and then do 23 minus 46 over there. So negative 0.026, and then I have 23 times negative 23, and I'm going to use my calculator to help me on that one. So negative 0.026 times 23 times negative 23, I get positive, and you can double check my work, I get 13.754, and the units are in yards. So about 13 3/4 yards high for the kick. My final example that I'm going to show you guys has to do with a bridge, and it says the Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. So if you can see, these suspension cables kind of model a parabola. It's a little parabolic shape, and they give us this funky equation that goes along with it. Now, one of the things that you might notice about that funky equation, as ugly as it is, that is in vertex form, which is great because it's easy to find the vertex. So it says, what is the distance d between the 2 towers? We want to know how far it is between these 2 towers, and it's not very clear how to get it, at least initially. But the first thing you might notice is, if I can figure out what this vertex is, I know since these 2 towers are reaching the same height, 307 feet on both ends here, this vertex splits that right in half, the distance from one tower to the other. So if I could actually find the vertex, I know that's halfway from one tower to the other. So because this is in vertex form, it's actually quite nice. The h value here is 1400, and the k value is 27. Now this, let me see if I can zoom in here a little bit. So really what we're looking at here is this coordinate is at 1400, 27. Now the x value then from here, from the origin here, is 1400. Now it stands to reason, if that's 1400, then the distance from the vertex over to this tower is also 1400, thereby answering the question. If I add 1400 and 1400, I get my total distance. That would be 2800. So if we add these together, we get our answer, 2800, and I think the units were in feet. Now that appeared to be something that was going to be pretty tricky, but just finding the vertex was really what it's all about. And you also had to know that you really didn't need the y-coordinate. It's not asking for how tall is the suspension cable at its lowest point or anything like that. Just wanted the overall distance. So if you pay attention to what's being asked, sometimes you can get yourself out of a little bit of extra work. What I'd like you to try now, I gave you 2 problems very similar to the ones that we just went over, and I'd like you to give them a try on your own and see if you can figure out how to answer both of them, and we'll talk about them tomorrow. Thank you very much for watching. We'll talk to you then.